Hello everyone. Today we will start with discussing the derivatives of exponential and logarithmic functions. And we will use the delta method to find the derivative of the exponential function. So as you know, derivative is just the slope. So we will start with our basic definition of the derivative. So we know that dy over dx, by definition, if you want to figure out the derivative, so dy over dx is equal to limit h approaches to 0, y of x plus h minus yx over h. And then we plug in the values of the function. So in this case, our yx is b raised to power x. So if you replace x by x plus h in the given function, so we get b raised to power x plus h minus b raised to power x over h. So in the next step, what we can do is we can use the rules of exponents and we can split b raised to power x plus h as b raised to power x and times b raised to power h minus b raised to power x over h. So now we can see that b raised to power x, which is a term independent of, so this term is independent of h. So we can take this outside the limit. So we can rewrite this entire expression as limit h approaches to 0 and b raised to power x can just come out from the limit because it's independent of the variable h, and inside we are left with v raised to power h minus 1 over h. Alright, so if we want to make it a little bit more simpler, so this is a times b raised to power x. So we got dy over dx is equal to a times b raised to power x, where a is equal to limit h approaches to 0, b raised to power h minus 1 over h. Alright, so what is the advantage of doing this? So this is our slope of the function y, and if you remember from the top, y is equal to b raised to power x. So basically what we are saying is d over dx, b raised to power x is equal to a times b raised to power x. So we can see that the slope of any exponential function is proportional to, so slope of any exponential function is proportional to its height, right? So if you want this slope to be equal of the height, so it means we must have a equals to 1. So that will help us to make slope equals to height. Alright, so in order to do this, so and this happens when we have a special base, and that base is number e. So let's try to do that substitution. So I'm going to call this as number 1, and let's try to figure out what is the value of base when a is equal to 1. Alright, so let's put a equals to 1. So this implies limit h approaches to 0, b raised to power h minus 1 over h equals to 1, because here we said that a is this number and we are just plugging in here. Alright, so moving on. So if we just a little bit more manipulation, so from here we will get that e raised to power h minus 1 over h is equal to 1. So let's solve this for b. So we will get b raised to power h minus 1 is equal to h. So b raised to power h is equal to 1 plus h. And then we need to take 1 over h power on both sides. So we got this expression. So basically from here we got that limit as, so b is equal to limit h approaches to 0, 1 plus h, 1 over h. So when a is equal to 1, this is what we were trying to figure out. When a is equal to 1, what is b? So in order to figure out b, we need to figure out this whole limit. So for that, we will figure out the table. So I'm using some values which are closer and closer to 0. So from this table, we can see that as h approaches to 0, b is approaching to 2.71828. And this number is e. So as h approaches to 0, b approaches to e. And we can use this in our number 1 equation. So using the value in number 1, we get, so our number 1 was derivative of b raised to power x is equal to a times b raised to power x. So that was our number 1. So if we use, so using this, h approaches to 0, b approaches to e in number 1, we get, so in place of b, we write e, and a is 1, and then e raised to power x. So from here, we got the formula that derivative of e raised to power x is equal to e raised to power x. So it's always a good idea to know some theory that where does a formula come from. So for the exam purposes, I wouldn't ask for the derivation, but you should know the applications of this. So you should know how to apply this to solve the problems. Alright, so that was when our base is E. So what if our base is not E? So let's say our base is some other number, E. So let's say our base is A. So what happens in that case? So we will try to figure out what is the derivative of e raised to power x. In order to figure out the derivative of a raised to power x, so we will start with, so derivative of a raised to power x. So what I'm going to do, I'm just going to do a clever way to rewrite this expression. So a raised to power x can be written as e raised to power ln a raised to power x. So remember, we know that exponential and logarithmic functions, they are inverse functions of each other, and we can write, so they're going to cancel each other's effect. We can write a is equal to e raised to power ln a. So in the next step, again, we're just going to rewrite this again in a clever way. So this is e raised, and also we know that the exponential formula. So if you have something like this, so it means the powers are just multiplied. So I'm using this rule of exponential. So d over d raised to power d over dx is e raised to power ln a times x. And derivative of, so this you can consider just as a constant. So derivative of e raised to power x is e raised to power x, but now in place of x we have the whole different expression. So it will become e raised to power ln a times x, and by chain rule we again need to take the derivative of whatever is the power because it's different than x. So we got e raised to power ln a times x and times ln a. And now we know that e and ln cancel each other's effect. So this is simply a raised to power x times ln a. So we got that derivative of a raised to power x is a raised to power x times ln a. So if we have a different base, so we have this extra expression that we need to add to our formula. So derivative of e raised to power x is just e raised to power x, but derivative of any other base would be e raised to power x times ln of that base.